Every circuit breaker has a profile of tripping behavior. These are represented on graphs called time current curves, or trip curves. After this course, you will be able to identify and define 3 ranges of tripping on the graphs, and relate those ranges to trips from overloads or short circuits. You will also be able to distinguish the time current curve of a classic thermomagnetic tripping breaker from that of an electronic tripping breaker. On some time current curves, you will see that you can adjust the tripping responses. For our residential miniature circuit breakers, adjustable tripping is not offered. For residential solutions, we can give you a better cost advantage in offering variety of circuit breakers with differing tripping responses. Our molded case and insulated case circuit breakers do offer adjustable tripping by electronic means, and in some molded case circuit breakers rated 250 amps and over, there is adjustment that can be made to the magnetic trip as well. The means by which the tripping can be adjusted will be addressed more in the upcoming courses on molded case and insulated case circuit breakers. Before we look at what is being measured, let's first look how it's being reported on the graphs. Both the vertical and horizontal axes of the time current curves are represented in what is called a logarithmic scale. You'll notice here that as 1 is at the bottom and 10 is halfway up, you would expect the top to have 20. Rather, it is 100. In a manner of speaking, using a logarithmic scale gives us the means to give a report on much greater ranges than we would be able to using a linear scale. Our vertical axis is reporting time in seconds. Moving down, we represent faster responses. Moving up, we represent slower responses. The horizontal axis is reporting multiples of rated current. Notice these numbers are not amps, but multiples of the circuit breaker's rated amperage. For instance, if this time current curve was reporting the characteristics of a 20 amp circuit breaker, 2 would not mean 2 amps, but 2 times the rating of the circuit breaker. In this case, 40 amps. We simplify and clean up this time current curve so we can focus on the shaded green area in between the curves and what this represents. Again, we have time in seconds on the vertical axis and multiples of rated current on the horizontal axis. We've been looking at a PowerPack B circuit breaker's time current curve, but all time current curves will have similarities of a lower and upper limit of time showing when the circuit breaker will trip for a given amperage. There are 2 curves with a shaded region between. At a given current that is over the rating of the circuit breaker will experience a trip somewhere in the shaded range. For example, on this time current curve, at an amperage 10 times the rating of the circuit breaker, using the logarithmic scale on time, we see a trip will happen sometime between 3 and 8 seconds. The time current curve is made up of 3 distinct ranges. These ranges identify the tripping responses to overload faults and short circuit faults. First, the long time trip values. This range represents the thermal trip response due to an overload or overcurrent condition. You'll notice the long time trip curve has an inverse time relationship. That means for this range of the time current curve, the lower the current, the longer the response. The higher the current, the shorter the response. This brings us to short time trip values. This range represents one of two ranges of the magnetic trip response due to short circuits. For short circuit faults pulling higher amperages, our response is shown in this third range of instantaneous trip values. You can see for this time current curve that whether at an amperage of 100 times or 1,000 times the rated current of the circuit breaker, the breaker will trip by the same maximum time limit. In our instantaneous trip responses, you'll see that we can respond as fast as the spike in the current waveform. Before this course, we learned about the magnetic response. We learned how this is possible. But here we'll just mention that the time current curve shows the trip response time in these higher amperage short circuit faults happens in no more than one cycle. At 60 Hertz, this would be about 1/1700th of a second. Now, why do some time current curves show a line at one cycle and at a half cycle? Circuit breakers that share a frame and the same amperage rating can have differing short circuit protection levels. This will be discussed more in the later course, Selecting Circuit Breakers. But for now, we wanted to at least point out that some circuit breakers may share the same time current curve with notes on it to point out differing trip values. We've been looking at the time current curve for a classic thermomagnetic response. However, our time current curves for electronic trip responses look much different. If you overlay the electronic time current curve over that of a thermomagnetic, you'll see a greater range is offered. In this greater range, you can adjust this electronic trip circuit breaker to one of the tighter tripping response time curves. Again, these electronic trip responses are only available on the molded case and insulated case circuit breakers. This time current curve is for one of our insulated case master pack circuit breakers. Zooming into these distinct ranges a bit closer, you'll see that each has a number. A full explanation of these numbers needs to be saved for a more advanced class. But for now, we'll say the numbers correspond to settings on the electronic trip unit rotary switches. As seen here, this rotary switch has 9 settings. Each setting matches to a set of the distinctive time current curves for the electronic trip unit. In review, to be able to identify ranges and values, remember that for a time current curve, you need to know the amperage rating of the circuit breaker to understand what the multiple rated values of the circuit breaker would be. Remember that the trip responses have a trend of an inverse time relationship. The higher the current, the faster the response. Remember, the upper range for lower multiples of the rated current represents the long time trip values. The vertical part of the time current curve represents the short time trip values, and the lower, flattened out part of the time current curve represents the instantaneous trip values. Identifying these characteristics, you'll be well on your way to reading time current curves for circuit breakers.